Hi there. Hello. My name is Brunia, and today we dive deep into the fundamentals of artificial intelligence in relation to the virtual venturing project, which is my project. And I had earlier introduced according to the very first video on this channel. So, um, the here the fundamentals of AI. It is a summary of the Alison course, which I got up. So I'm going to be a little bit faster so that I can finish this on time. So introduction to, according to the modules, I'm going to be going again, basing on the modules. That is from module 1 to this time round, I'm stopping on module 9. Yeah, and as I relate to my project or my understanding and the integration of how my project integrates these fundamentals to bring out something reasonable. So basically, the first one of this is the introduction of artificial intelligence, whereby we go on the historical trends of how AI comes into existence from the origins of the very, very first scientists to make their researches there. Alan Turing and Leonardo da Vinci, some other, depending on whatever, on all their researches. So diving deep, definition-wise, we can take AI or artificial intelligence as a field that basically devotes on building artifacts that are capable of thinking or to have capable of an intelligent behavior, with dimensions that are wide, ranging from weak AI to strong AI. Mostly right now we are on weak AI, that is to include the open AIs and ChatGPTs and series. Strong AI is still in building. We haven't gotten there. That's what I can say to my think and what I have read now and to my knowledge. Machines with consciousness and self-aware understanding, I think we haven't gotten there. So in like historically, the first 30 years of early AI research revealed that for a machine to be gauged as intelligent, it requires knowledge. So that for us to get to strong AI, our machines have to be with the knowledge. So here I go to the characteristics of frameworks or future prediction and trajectories of AI. Basing, I'm going to go from historical, current, and future trends of AI. Here it goes from the symbolic logic, which directs it to the statistical learning, and then to deep learning, like the historical artificial intelligence innovations. They just did the basics. Say like they studied the logics or the symbols, system hypothetical symbols, then to then they do just statistical learning, simple learning, though not a lot of data, then to the deep learning, which I think dives now goes to the current trends, because earlier, like in history, deep learning on neural networks was not that big. So which is currently making, I can say, like a breakthrough right now. To here we start from where the other one stops, like deep learning, big data. We can call it data mining, real-time AI. We have seen systems that work in real time, but they're AI based, generative AI that is open source, and neural networks. Mention it, but a few large natural language processing. So for the future of AI, we can say and integrate they look forward to integrating domains, like different information of different domains for into the AI, so that it can be a multimodal or a layered system that does a lot on its own, so that we look, because a human, according to guessing on a human intelligence, humans can think on they can come up with solutions, given even if you don't give, like they have a huge model domain knowledge based with AI, which AI lacks for now. Maybe that we could say it's the future we see for AI. And interpreting this AI module 1, history, trends, and current. Um, into knowledge into my vet project, which in other words is an event, virtual event touring platform. Here we see that basically mine has the multimodal integration whereby it is combining a lot of features, that is the vision, the language processing, generative for the linguistic support, and all those features to come up with what I needed to do, that is democratize event experiences globally or preview of events. In terms of the philosophy, I could say this is where my project is still basically weak AI, because however much it can simulate experiences, it does not have the consciousness just like a way human can have. So it is still on weak AI paradigm. Going deeper into projects evolution or mirrors, data mining and stuff, it uses database. Like you are going to feed it with a lot of data. We are going to feed this model with a lot of event videos and photos and what, for it to be able to reconstruct experiences or even make predict the future experiences. So that is how it can, and it also is a generative model. So, and when we get it to the types of intelligence by Mr. Howard, uh, it what I can say, it encompasses spatial intelligence for the 3D reconstruction. That is, it mimics what memories of people that have gone to these events. Then the linguistic intelligence, whereby it summarizes, that is through the natural language uh, platform. I mean, processing for the captioning and image captioning, not forgetting the predictives. So in this second module, where it's we dive into the problem solving and in AI, basically AI problem solving involves finding a sequence of actions that lead to an initial state, like that lead from an initial state, like all the actions that an agent may take to get to the goal state, that from to the desired solution. So steps involved in this can be, it the agent gets to know the problem precisely, analyzes it, isolates or represents task knowledge, and then lastly chooses the best solution for it. In this state space, it involves the states, operators, goals, and such spaces. For the problem types heuristic, in this slide, I go through the problem types, heuristic, functions, and such strategies. The problem types, we have two of them. The well-defined problems, whereby they are straightforward, or they get to the point, like they are well-defined. I mean, they are not ambiguous, if I can say. Then ill-defined problems, they are ambiguous, like they're not so direct. They're confusing, okay, in short form. So here in characteristics of this, it requires the domain specific. For us to get to know the problem we're solving, we have to know the domain under which it falls. Then the state space size, branching factor, solutions, etc. etc. A heuristic function here, this one estimates how close our state is to the goal. And the purpose of this is to make sure that we don't waste time or speed up the computation power for our agent, and by letting it focus on promising path rather than wasting time on the path that would never lead it to the goal. So admissible heuristic here, it works on how do I say it? Guarantees optimize. It works on optimizing search. So different strategies, such strategies can include uninformed search, that is breadth first search and depth first search, and informed search, which is the heuristics, which is the greedy search, like it has no given algorithm. Hill climbing, etc. Relating problem solving to my model here is using the data mining, this model of ours classifies, like classification problem reframed as state space, e.g. categorizing event types for reconstruction. If this is a tech event, You can have a concert, tech event, conference. So this mode of ours categorizes them. So in other words, you're not going to go under a category of tech and you find a concert or a music concert in those events. It's not going to create memories, to recreate or 3D reconstruction of memories that are not matching. So intelligently, still connects to the logical mathematical intelligence of structuring events as is formally. So the philosophy here, it addresses the frame problem whereby it determines which event aspects are relevant for reconstruction. No matter how many videos we feed into it, it's not meant to mix them up, rather than it uses that logical or frame problem to find which one goes where. So initially, the initial state can be to a raw event data footage, then it which equates to an AI processing algorithm 3D reconstruction. Like if the video is equal to a text, then reconstruct the memory, rather than which develops an immersive virtual event space experience. Mm, when we go to the problem solving by search here, it's like an addition to the previous one. So here we go through the advanced search techniques, which includes the breadth first search, which I mentioned before, alphabet pruning, problem relaxation, mention it. So in other words, in here to relate it to my project, this our 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 event touring project, it builds a tour as an and or task, or you can call it and or graphs. So we need a model or CD scan that narrates an or AI generated graph. Here we also taken the data mining clustering, whereby we cluster users over that like in this I mean like users that like given events are clustered. We cluster users according to which events they prefer or they have attended before through getting their data. And then whereby events shrinks the search space for recommendations. So we wouldn't like a user who is more involved in the given event to have a notification of an event whereby they are they are not interested in. So intelligently, it's like a spatial intelligent type whereby the model has to take on a role to study the spaces where these memories are created to deliver. So philosophically, it brings back to the simulation argument whereby by Mr. Bostrom of Are We Living in a Computer Simulation, whereby we simulate event experiences to our users. Knowledge representation and reasoning in this. As you know, knowledge has a hierarchy. It goes from information we feed into it. It may mean data, which it transfers, processes to information. Then from the information, it derives knowledge. That's how basically human brains think. And we want to relate it to AI. So symbolical AI just uses logic-based just data, and through the explicit rules, it comes up with the knowledge. And well, that's why I also get the connectionist AI, the neural network, or the feather trend, or you can call it distributed learning. It is implemented in levels as stated below. So when I try to partake my event touring platform, if the event type is correct, or its concert and venue size large, then it will equate to the user spatial audio reconstruction. So it picks that information. If this is the event type and this is the venue, then because you're not going, it is it I request I expect it to when it is reconstructing memories, it has to be with the knowledge of the size of the venue, the type of the so that it reconstructs memories. Or in other words, even it previews or it's before it gives me a preview of an event that has not yet happened. So when we go to the first order logic of all, it encompasses various components that is more expensive than prepositional logic. That is the previous one we are from talking up. I mean, this one, the knowledge represented just logic symbols, and explicit rules to come up with the solution. But this one here, it is like it has various quantifiers, functions, and objects, relations, axioms, we can say rules or theorems, just to get uh, a solution or to come up with a decision. That's what I can say. So how the first order logic works in my vet project, it encodes a domain knowledge. For example, for all the events, they are all the events given a given location or located at, that is the most domain knowledge, the best knowledge, domain knowledge it can get. So you can also say like for all events X, and it has a video with a given quality because it has to provide quality reconstructions, then you can create a reconstruction 3D. In this, of course, it involves data mining. Most of these, as I relate to my project, they involve data mining because they work on data fed on there to give me results. Logical mathematics for the intelligence type it carries for that. Then the philosophical part of it is that however much it manipulates these false symbols I feed into it, this logic, that doesn't imply that it understands whatever I'm feeding. It chooses its semantics or rules to give me what I want, but it still doesn't mean that it has the consciousness or understanding of that. So inferences and rules and mention it, inferences and resolutions. In this is the key concepts here. We have the resolution principle, which automates the theorem proving. It's like you can say the first order logic inference. Yeah, that's how I can base it on it. So soundness, completeness, and most general quantifier preserves maximum generality. This the my project's inference, it is automatically derives optimal reconstruction parameters from footage quality lighting. I'm going to base on reconstruction because that's it bases on most AI modules, maybe, and also the future preview reconstruction of my project. So continually, it gets the inferring new facts from event features, event X, and it teams it up like with the jazz, with information given to it. Then it comes up with a general, let's say like a category. Let's say if you're to go in this event, you're going to find, of course, this type of artist or this type of speaker. Now then, period. So data mining, of course, because it corrects that one, then categorizes it to add effects of inference. Intelligent type, we can have the logical mathematical deduction, thereby if this event has this, then also the other event resembles this event, then they have the same artist on them, like it narrows it to deduction, mathematical logic. Gets to the Turing test and the lack of understanding, like it doesn't know what it's doing, but it does it perfectly. So reasoning and uncertainty would go to the probabilities, which is used to handle incomplete or noisy data. There's through here we have the bias networking, context dependencies, and updating beliefs or hypothesis evidences. So integration of this to my project is predictive analytics, where a user attends, we predict for what the user likes. If user B likes attending this, then we can predict and say, analyze, and then add in what they might like on their dashboard. Like, for example, you've been attending this, but you might like this type of an event based on what we have seen you attend. And then planning fundamentals here, sequencing to achieve a goal. In this, my my project here, it has the goal may be equal to immersive experience actions, which include the video processing, 3D modeling, structuring, mapping, mentioning to optimize a sequence execution. Then machine learning, of course. Machine learning in my vet project, it's all about machine learning, where this system of mine is going to be learning from multi-million sets of data to give me what I want. It can be supervised learning, unsupervised, or reinforced, but specifically, the vet is going to use supervised learning because it gets to use the data I feed into it, which is, I can say it is supervised to translate for the natural language processing, categorizing my events or sessions or artists. Then for unsupervised comes in when it is user clustering. There I don't even have to supervise this. It regression learning, I can say that it teaches itself then clusters the people using this platform. And yeah, logical mathematics patterns and the superhuman intelligence. That means it makes it more intelligent than a human brain. So in summary, I get to use all the I get to use all I summarize from the historical context up to the future trends and inputting my project significance, or that this is significantly if the my vet or virtual event touring platform demonstrates how AI fundamentals combine to create transformative applications that address real human needs for connection and culture access. Thank you for listening.